Hi everybody, Mal here. I figured I'd give another proper demonstration and explanation of the board and the correct way to use it. So I had a lot of people telling me and asking me to go through it again and just telling me that there's really basically nothing special about the way the board operates, but that's completely incorrect. The board is far more than just an inverter that's run off of a 5 amp hour supercapacitor battery hybrid. The correct way to use this system is, like I said, we created a very efficient negative resistant super joule ringer circuit, and we don't tap that power directly, we tap it wirelessly. And we can tap it wirelessly for a gain in power, and when we tap that power wirelessly, our input power that's feeding the circuit, our DC input power that's feeding the circuit, will drop to virtually nothing, while our wireless power output is at its maximum. The more power you draw from the wireless circuit, the less power your transmitter's input consumes. And in this case, it's a special type of transformer. The wireless pickups are a special type of transformer. And I'll basically just turn it on and show you. We perfected it further with the help from the community, and there's a little green alligator that comes off there where you would earth ground it for even better performance, just right there. So the theory and the practice of how you operate it is you switch the unit on, and we once again achieve the ability to recharge the source battery or supercap hybrid, whatever you want. You don't need to use a 5 amp hour supercapacitor battery hybrid like I use. You can use any modern 5 amp hour lithium iron battery. I'd prefer lithium iron because it's safer. It will still rapidly recharge, but a little bit slower if you don't have the supercapacitor hybrid version. So anyway, this is the amp meter that reads our power draw for the ringer circuit. I'll zoom in on it. As you see, we consume minimal power, so that circuit is on. And this is the wireless output of the ringer. Hopefully you can see that right here. There's no dead shorting of my battery occurring like a lot of other people were saying. I can dead short. This is a wireless transformer output from the ringer. I can dead short this output, and as you see, our power consumption drops to virtually nothing. So that is the effect I'm talking about. We have our wireless output dead shorted. Our power consumption is at virtually nothing. That is the magical effect I'm talking about. And then we take that output and we use that high frequency negative resistant output to rapidly recharge another 5 amp hour supercapacitor hybrid source, or it could be a just any other regular battery. It doesn't have to be exactly what I have, and the effect still works. And this is my multimeter hooked up to it in DC voltage, showing you the voltage. I demonstrated in my older videos that you can pretty much recharge any battery as long as it's not completely dead and screwed up. So that's how that works. We're not running loads directly off the high frequency negative resistant output. We're using the high frequency to rapidly recharge a storage medium that then runs an AC inverter for a time to give us the power we want. So this is a hyper efficient energy transfer system. It's obviously negative resistant, and I had a lot of people telling me that I have no clue what I'm talking about, when negative resistance is a plain as day phenomena you can read about. And also we achieved a plasma based isolation. This is the cold cathode spark gap discharge tube that looks very similar to a neon bulb, but it's a little different as for the cathode is a cold cathode material. That's the only difference. And we can tune the device now with these potentiometers for even more negative resistance effects. As you see, I tune this potentiometer to get either more plasma or less plasma within the spark gap discharge tube. It is a negative resistant cold cathode spark gap discharge tube. I know that sounds kind of like a mouthful. They're also nicknamed cold neon bulbs or cold neon tubes. And as you see, I will tune the it, and it will probably go up to 13.50 based on the tuning. You might have to tune it a little bit to achieve the rapid recharging effect, depending on the type of battery or supercapacitor or whatever you're charging. And the reason you need to tune it is because you're going for an impedance match on what you're trying to supercharge. And the supercharge effect occurs with that tuning, with that fine tuning with the potentiometers. And once you reach it, that rapid recharging effect will occur. And again, we have the ability to not just recharge a separate DC source. We now achieved plasma-based isolation. I don't know why a lot of people are calling me liars, saying that there's no plasma-based isolation. That is the plasma-based isolation right there. That is a plasma. That is a plasma bulb, cold cathode plasma. It's isolating the circuit. I can now connect this wireless output back to my input and recharge our source. We now achieve that effect again. As you see, the characteristic of the plasma changes a little bit when I connect it back to my source. So you have two options with this generator board, because we had a breakthrough with the plasma-based isolation. The circuit will not short out now when we send that power back to the input. So that was the breakthrough. You have two options. You can recharge the input, run your inverter from that, or the better option is you can recharge a separate source while consuming virtually minimal power from the trigger, which is this is just acting as your trigger. And this virtually never drains, is what I'm saying. And then this is what supplies you your power from the rapid recharging. But you have two options to play with this generator board. It's an experimental generator board. Can do what you want with it. Hyper efficient. You earth ground right here. This wire, you earth ground right here. You see, it's so sensitive, even me touching the earth wire causes the bulbs to get a little brighter and my power consumption to drop a little bit. So if I had the meter hooked up here, you would probably see it slightly recharging. And again, you would have to tune that output with the potentiometers, depending on the rapid recharging effect you're going for. So yeah, I don't know what else there is to debunk. I explained to you the principles of operation. We created a negative resistant super joule ringer circuit. We don't tap that power directly, killing our dipole. We tap that power wirelessly and resonantly with the correct resonant transformer wound around it. And we get a gain in power from the earth ground. The fact we created a negative resistance allows us to achieve a wireless power output at virtually no input. It's high frequency, it's fast, it can rapidly recharge secondary sources or the input source, the primary input, due to it being high frequency. And as you see, the sparks are little here now because I have to tune it again. So I have to tune it a little bit. There we go. You were basically tuning it for the largest sparks possible at the minimal input possible. And then you connect it to whatever you're trying to charge. Mess with the tuning a little bit until you get that rapid recharge effect. And you can basically just throw your inverter on the switch. Inverter will switch on. You have to have the manual off switch on the inverter because, like I mentioned before, inverters have parasitic power drain just by being connected to a DC source. The manual off switch is important because it stops the parasitic power drain from occurring. Now there's live AC here. You have to be careful. The board doesn't come with these exposed wires like that. This is just something I added to quickly plug in light bulbs and show you what it can do. So back up a little bit. So he kicks on. That's an LED, no big deal, consuming 5.7 watts. There's our voltage, big deal, boring, right? LED, but again, we can hook up an incandescent bulb for a time. And you don't want to pull more than 100 watts out of this guy, out of this output, because it was only designed, this model was only designed as a 40 watt unit, but technically it is upgraded, and you can safely pull 100 watts from it. And the interesting effects occur when you don't fully drain the power source here. You always want to maintain it at like a 70% charge, and then those rapid recharging effects take over, but you don't have to do that, it's up to you. And again, I'll switch the inverter off with the manual off switch, and we'll watch it recharge. Oh, and before I do that, well, here we go, come on. I'll show you that we were consuming 40 watts there at the load. Maybe a little less than 40 watts. So yeah, 35 watts. All wattage output for the device comes out of a watt meter. You know, I don't play around with power consumption. You can obviously see the output comes from a watt meter. And then our rapid recharge effect from the circuit takes over. Sometimes the bulbs will stop firing during the recharge process, and if they stop firing, you might have to tune it a little bit, but even if it stops firing, it should still work properly because the negative resistor takes over, that correct value resistor, and the earth connection. I noticed the bulbs fire once you hit a full charge again on your source. So the addition of the bulbs in tandem, in combination with the earth ground connection and that negative resistor, create just a very non-linear open system circuit that has very peculiar, highly efficient effects. So we're seeing it recharge here, like I've demonstrated in all my older videos. And I could probably get that to charge even faster based on tuning. Yeah, see? Alright, see how I tune this just a little bit now with the potentiometer? The bulb is firing, and that will probably say 13.35 soon. Based on how well we tune the guy. Make sure that switch is off. Is the inverter switch off? Yes, it is. Okay. So anyway, that should recharge soon. Make sure our spark is good. Alright, that's the spark we're looking for. So as you see, that should be the proper output that it needs to recharge rapidly now. So as you see, I'm demonstrating the tuning effects with it via the potentiometers. Yeah, see, there's the rapid recharge now. Because we tuned it a bit, users have that option now for the tuning. There's 3 potentiometers on the device. One coming off of, in series, a 0 to 200K potentiometer in series with our correct value 5 watt 30K carbon film resistor. You have to use carbon film because wire wound resistors will detune this type of RF system that creates these effects I'm talking about. So we have that one, which you don't really ever mess with unless you have the option for fine-tuning your resistance for the negative resistance. You don't really ever have to mess with that one, but it's there if you want the option. You also have the potentiometer in series with the plasma-based isolation part of the circuit. That's right here. So you have that option. And you also have the main potentiometer tuning option, which is the main one, which is firing between the negative of the circuit and the ground. So that's some more fine-tuning available to you. This is the main one you will be tuning. These two, this one and this one. These two are the main ones you will be tuning, not so much that one. But nonetheless, you have those options. And there's our charge on this device. I showed in this video how not having it properly tuned can cause it to almost not recharge. But then once you get that thing properly tuned, the rapid recharging effect takes over because you impedance matched your power with what you're trying to rapidly recharge. And again, the source would be, the rapid recharge effect would be even more pronounced if you earth ground this part right here. So once again, I'll sum the system up. We have a 5 amp hour supercapacitor lithium battery hybrid source, Life EP04. It has built-in BMS, 5 amp hour. These guys sell for about $350. I have a commercial electronics account with Newark where I get mine. I believe they're made in Brazil. So anyway, again, sum up the device. This just acts as our trigger. It powers up our negative resistant ringer circuit. That power passes through an ammeter so we can monitor what's going on. We power up our circuit here, the negative resistant ringer. We've created a highly nonlinear circuit with the fact we have cold cathode spark gap discharge tubes in the circuit in special parts, and we can fine tune it with our carbon film resistors. We have a military grade tip 35C all metal transistor. We tap our power wirelessly without killing our dipole. And the fact we're in that negative resistant resonant state, like I said, when we tap that power wirelessly, we don't put a load upon our input source. The load power actually decreases upon our input source as our wireless output power reaches its maximum. So these are the full explanations. And then you take that power and you can fine tune it with the potentiometers, the 3 potentiometers, but in this case you just would basically use the 2 from potentiometers here for most of your applications. And then we take that output, we take this output, that's a very rapid negative resistant high frequency output. Depending on how you tune those potentiometers, you will have anywhere from 32 volts DC to 80 volts DC, anywhere from 50 to 300 milliamps. I've always seen it in the higher end range, over 200 milliamps at about 80 volts DC. And that's the effect that rapidly recharges your source, or you can feed it back to the input. And I favor these guys because they have built-in BMS and they can handle up to 220 volts DC at 5 amps with the built-in BMS. So it's very simplistic. You don't have to worry about another battery management system or a charge controller. You literally just take the output, hook it up into here, and you're good to go. And as you see, we're at 13.39 with that rapid recharging effect. So we're rapidly recharging a separate source at virtually no input because the negative resistance took over. We're at virtually no input. And while we're at virtually no input, the system still generates a little bit of wireless power you can tap and play with. Right here, hopefully you can see that okay. I love these little detector lights. This is just an Arvamenko plug. Here's a good look at it. It's literally just 2 diodes in a pigtail configuration. And you hold the bottom here, and you would touch it or bring it close to parts of the circuit, and you can see you either have a wireless output or a 1-wire output of power. And it even glows just me bringing it near the trigger source here that's running the ringer. So there's our charge. And I've shown videos in the past where I didn't even fine-tune this. This is rough tuning. I've had this thing very rapidly hit 14.20 volts. Very rapidly. And then you tap a little bit of that charge. You use that power till you go to like 13.80. You shut your load off. And then you just let it hit 14.20 rapidly again. And you can keep playing with it. Do what you want. So I hope that fully explains things. I have a lot of annoying people telling me I have no clue what I'm talking about, that I'm a liar, that all the things I'm saying don't exist, they never heard about this, they have master's degrees and PhDs in electrical engineering, none of this makes sense. Well, I'm sorry, they don't teach any of this in your school systems. And I have a 2-year degree in electrical engineering. I was never taught a fraction of this stuff. And in case you're unaware, the most popular YouTuber guy, I believe his name is Electro Boom, he didn't even believe the Slayer exciter circuit could work at first. He has a video out there where he was saying the Slayer exciter circuit is impossible and wouldn't work. And then he ended up proving himself wrong in that video. Anyway, I'm not discounting him in any way. He's absolutely a genius, and he's probably very gifted with mathematics, but I'm just pointing out how absolute experts and masters can be very wrong in certain things, especially when it comes to well-proven theoretical concepts that are not at all taught in the college systems or the educational systems. I've had advanced AI chat systems help me design this, and they absolutely tell me it's possible. So, in the primordial electric grid, they literally had electricity vanish into the ether, they believed, or into counter space. What occurred is they believed when they transmitted large amounts of power, something wasn't quite right in the primordial electrical system. And they literally had the destruction of energy. It just vanished. They don't know where it went. It just disappeared either into another dimension or somewhere else. It just disappeared, maybe into the ground. They have no clue where it went. And if you ever follow or read some of Eric Dollar's work, he's an absolute electrical genius. He believes in the theory of energy synthesis, and he has a lot of work regarding that. And he's most likely ultimately correct, because if you take an Occam's razor approach to things, all the main scientific theories break down ultimately when you hold it to a magnifying glass. If energy cannot be created or destroyed, where did the energy to start the universe come from? How does the universe keep expanding? What fuels its expansion? So these are main questions that are occurring here. Energy conservation only occurs in closed mechanical systems, in closed circuits. That's what the original rules apply to, not open, wireless, magnetic, resonant power systems. that are in tune with the Earth, that are highly nonlinear, that have cold cathode spark gap discharge tubes. This is a solid state device, no moving parts. A lot of academics that I'm speaking to have a very hard time getting it through their thick heads. This is not a perpetual motion machine. There's no moving parts. You wouldn't call a solar panel a perpetual motion machine. There's no physical moving parts. It's magnetic switching. Yeah, there's no moving parts. Solid state device, highly nonlinear because of our plasma, our high frequency fast switching Scotty diodes, our earth ground connection, the fact we created negative resistance, the fact I documented that, the fact I showed you that, proved it to you. There's countless books and articles explaining negative resistance. All modern academics focus on is closed electrical systems. They focus on closed mechanical systems and always scream, oh, it's never going to be over 100% efficient, it's never going to work. Well, no kidding, it's never going to work that way. You have a closed circuit system, but it's by the definition loss. The type of power we use is by its definition loss. It's positive resistance. When you create amperage in your circuits, the amperage is the amount of heat and loss occurring within your circuit. That is the wrong form of power. It is by definition loss. It says that in some of the ancient textbooks, especially written by Steinmetz. And the correct form of power to use that is not by the definition loss is a type of cold cathode-based electricity, a type of wireless resonant power that I'm demonstrating in this video, that once you achieve a form of hyperresonance in the circuitry will draw in excess power from the environment, either from the air, from an earth ground connection, or from a heavy metal connection you connect the earth ground to. This could be a large metal plate or an antenna, maybe similar to the Moray valve, but yeah, that's our charge right now. You wouldn't call a solar panel a perpetual motion machine. You wouldn't call an antenna a perpetual motion machine. The term doesn't apply. It's ridiculous. There's no moving parts. So that's that. I hope I explained it. And all the ancient electrical engineers, the masters that gave you our modern world, not Einstein, Tesla, Steinmetz, Maxwell, all the masters that gave you your modern electrical engineering world believed that it's possible to create a power generator or an arch form, the correct arch form for power manifestation with virtually no input or no prime mover. So, with that being said, I hope the theories stated here get people thinking, and I hope I fully explained everything. And thank you, everybody. Feel free to like, comment, subscribe, and if you want to purchase a system, the link to our Patreon is in the video description. Wait time for the boards now. Existing orders shipped out. Wait time for boards is anywhere from 1 to 3 months. Take a while to construct and fine tune. And once again, thank you, everybody. Feel free to like, comment, and subscribe.